Hello everyone. Welcome to today's discussion session or the live interactive session on geology and soil mechanics. Today is the 12th discussion session that we will be having. So, in the past 11 weeks, we have gone through a myriad of topics ranging from the basic introduction, which dealt with what soil is actually and what are the basic index properties of soil. From there we started, and now actually we have reached to a very advanced stage, right? So I hope that all the concepts that were discussed in all these 11 weeks were are clear to you, and you will be able to perform them properly uh, in your exams, right? So in today's session, what we will be going to do is that we will be basically uh, solving some problems from the uh, main topics that we studied in all the 11 weeks. So ranging from say uh, the retaining wall design, the earth pressure theories, and so on. Okay, so we will be solving some problems today, and apart from that, tomorrow we will be having one more class. Okay, one more discussion session actually, or a summary session. You can say, you can call it as a summary session. So tomorrow we are going to have one more summary session from 12 noon to 1 p.m. So only for 1 hour we will be having a summary session. So tomorrow we won't be solving problems, solving anything. So just 1 hour we will be discussing everything from the start to the beginning, the basic theoretical concepts that we have studied in this course. We will be just recapitulating all these things. Okay, so today will be the last problem solving session, and tomorrow we will just have a rough discussion session of 1 hour duration. All right, so I hope that you all of you will be joining tomorrow also, and what you can do is that you can ask all of your doubts, whatever you have up to for all these 12 weeks. If you have any doubts, you can ask me. Okay, and I will try to solve them. If you have any doubts about the exam also, you can ask me. I will try. If I will try to solve your queries. Apart from that, uh, if you want me to solve any problems, I will solve. Else what we will do, we will just revise all the concepts once. Okay, we will just revise all the basic concepts once. Okay, so with this, let us start today's session solely by solving some of the problems from the topics that you already have studied, uh, in the course of this, in the run of this, during the run of this course, right? So let us start. So we won't be solving that difficult problems. We will be solving normal basic concept problems related to basic concepts only. Okay, so let us start. Okay, So a retaining wall with stratified backfill and a surcharge load is drawn. Estimate the resultant thrust and its position. So we have solved a lot of problems similar to this, right? We have solved many lots and lots of problems regarding this. So solving this should be a cakewalk for you. Okay. So I will just draw the retaining wall. Say this is the retaining wall. Basically we have a surcharge layer. Okay. This is 3 meter, this is also 3 meter. Alright, so this is the retaining wall, the stratified backfill. So two backfill layers are actually there. What we need to do is that we need to estimate the resultant thrust. Okay. So how to do that? Please try to do. So tell me, what are the forces that will become? So one lateral thrust will be coming from the surcharge, right? So from the surcharge, we'll be having something like this, right? Right. So let us call this as small PA1, and then due to the soil weight, we will be having a triangular variation. This is nothing but say small P2. So for the top soil layer, in the top soil layer, okay. Okay, then it will be y1 bar 3 from the bottom we are measuring, huh? 3 plus similarly right. What 3 plus what is capital PA1? This will be how much? Half into 15 into 3. Alright. So PA1 is acting at 4.5 from the bottom. PA2 is acting as 4 meter from the bottom. Now for the bottom soil. What will be PA3? Right, so this PA3 is nothing but like this. I will draw here like this PA3. So this will come out as how much? Please calculate. So capital PA3 is PA3 into 3. Alright. And one more thing, YA3, nothing but 3 by 2. This one. Okay. Now next is your C. Now it is a C5 soil at the bottom, right? The bottom soil is what? C5 soil. So there will be that negative portion also that it will be coming into the picture. So the whole variation will be something like this. Isn't it? It will be something like this. Now what is this? This much? This we are calling it as PA4. So PA4 is nothing but minus twice C over Ka2. So what is C here? 10. So this one comes minus 60. Okay. So PA4 is so this one what we can do is that this one, so you know that what is the term gamma z. Ka minus twice root over K, right? So this one we can separate it out as say a surcharge of minus twice root over K, right? So this one we can separate it out. You can write it as a surcharge because it is constant along independent of the height and constant all over, right? So this one we can separate it out, right? So this one what we can do, we can separate it out as like this, right? So this one is minus twice root over K, it's negative. Like this we can write this out across 3 meters. So this is just an alternative way. So previously we saw some different, but this is just considering the same forces just in a different way. Okay, different view of same seeing at the same type. Okay. Okay. Correct. Now what will be the fifth one? The fifth one will be gamma z root gamma z k, nothing but gamma into height into Ka, right? So this is positive, this is nothing but gamma into 3 into K, and this combined with this actually gives us like this diagram that we finally use. Okay, so this is the combined diagram. So there this diagram we are separating out as this, you are writing it as this and this. Obviously you can write this, right? Isn't it? You can write or not. This term we can write it as surcharge term and this normal variation term, isn't it? You can do that, right? So that is what just we are doing here, nothing extraordinary. Okay, this is what we are doing here. So this one we are calling it as PF5. So PF5 is nothing but what? This is the 3 by 3. 1 meter 3 by 3. Done. So finally final PA this plus this 9.99 22.5 plus 1116.16 plus minus 50.34 okay. So this one will come out as, calculate this one, $161.6. Okay, therefore So if you do that, this will come out as that. Okay. So at 1.84 meter is the point of action. Alright. So problems are quite similar and easy, like so whatever how we solved in the all sessions, that's a plus. Here, for the C5 we are looking at the total diagram, the different point of view to solve the problem. That's all. Others, rest apart from that, everything is exactly the same. Okay, so nothing to worry. The section of a cantilever retaining wall is drawn below. Find the factor of safety in sliding, overturning, and bearing. Okay, so I will draw the retaining wall. Safe bearing capacity. Okay, so these are the this is the given dimension and the properties of the soil and everything for the cantilever retaining wall. So we need to find the factor of safety in sliding, overturning, and bearing. So how do you do that? First, what you have to do is that first thing what you need to determine is the earth pressure. Okay, the earth pressure you need to determine. K into what? Plus Q. From here we can get assembly. Alright. So what is PA? So if separately I write 43.617 plus okay, so like this, right? So this is one is the surcharge. This much is what? K into Q. So 7.27. Okay, this is Q1 say. Then we have Q2C. This is K into the gamma into Z. Alright, this one is P1, this one is P2. Okay, now what we need to do is that we need to make a table so that we can find out the total load setting acting on the returning wall and also the moments we can find out, right? So we'll make a table. So first will be so first let us say P1, let us say what is P1? 43.47. So where is the moment arm of P1 located? So at 3 meters, right? From the base it's 3 meters, right? 3. So do this 43.47 into 3, do this and write them there. Now for P2 it will be what? 6 by 3, that is 2 meters. You write this down. The weight of stem is how much? Total height is 6 minus 0.5, that is 5.5. 5.5 into 0.5, sorry, 0.4, it is the width. 5.5 meters into 0.4 meters into the unit weight of concrete is 24. So 24 into 5.5 into 0.4. So do this. Let us see how much we are getting. And last one is weight of base. Okay, base is nothing but what? 3.5 meters into 0.5 into 24. Calculate this. This one 42 and this one will be 52.8. So the moment angle here is 2.2. So how 2.2? 2 meter, right? 2 meter from the heel you are calculating. Okay, from 2 meter and the center. So 2.2 from here. Okay, so because we are finding out the point of rotation about this, right? About this heel. What this one will be 1.75. 1.7 nothing but 3.5 divided by 2. It is 1.7. So 43. So do this. How much? Check these values. Okay. And now we have more quantities. So I will write here weight of backfill. Okay. How much? How much is the weight of backfill? 3.5, sorry, 2 meters into 5.5 into 16. 16 into 2 into 5. Right? This is 2, this is 2, 5.5 into 16. This is the momentum. 1, right? 1, rectangular, so 1. So, last is our surcharge. Surcharge is how much? 70. 70, right? 35 into 2, 70. And again 1. Okay. So total, now we'll do total sum of force in vertical direction RV is equal to how much? Add all this. Add 43.47 plus 59.82 plus 52.8 plus 42 plus 176 plus 70. Add all this and write here. Please all add all these values. Add all these values. So how much is the total? 340.8. Yeah. Similarly, uh, what will be the horizontal force that is acting? Horizontal force is coming from where? Nothing but PA only. So PA is the only contributing horizontal force. So some horizontal PA. Okay. Okay. And also from here you can get the sum of moments, total sum of all the moments. Okay. Sum of moments 130 plus 19116. Do all this and add it up and write down. Please add all the moments and tell me how much is it. Yes, CX85. Okay. Now X bar. X bar is nothing but the point of application of the resultant. So how will you find out? X bar is nothing but 685.71, right? Okay, so this is where the resultant vertical load is actually acting. So eccentricity, then we can from this we can get the eccentricity. Okay, so base pressure, is less than the safe bearing capacity, so it's fine. Again Q mean which is positive. Okay, that means no tension in the zone. So this should always be positive, right? Factor of safety in sliding, nothing but RV 10 delta. So what is RV10 delta? RV10 delta is nothing but the frictional resistance. Okay, this is the frictional resistance. And what is delta? Delta is nothing but friction angle between basal and bottom surface of base of the retaining wall. Okay, so RV you know how much, 340.8 into 10. So delta generally we take 2/3 of 5. Okay, and divided by, this is so all right. And one more thing, uh, uh, that that you need to do is find the factor of safety in overturning. Okay, factor of safety overturning. So factor of safety overturning will be what? What is causing the overturning? What is causing the overturning? Overturning is caused by nothing but PA into what? The Y, where this resultant PA is acting, right? Divided by the resisting moments. So what are the resisting moments? Resisting moments is nothing but this. All these are resisting moments, isn't it? All these are what? Resisting moment. So I just wrote it opposite. Will be, okay. So find this Y, find this Y, and do this problem. So find this out. Okay. Calculate this yourself. Okay. Calculate this yourself. So F is overturning A into Y. So what is Y? Y is nothing but a resultant of here. From here you can get the Y, right? Where this resultant P is acting, that height you can get, right? So then if you do this, you will get the vector safety against lighting. Okay, just give me a second. Okay, right? So understood this, right? So calculate the overturning factor of safety by yourself. Fine. Now let us see the next problem. So this problem is exactly almost similar to whatever you solved in the previous class, right? You solved some problems where you had to calculate the factors k, so that you can find out the stress at a point in the soil, right, below a rectangular loading, right? So that similar problem we will be solving now, but that's a little bit different, but almost the same problem. All right. So rectangular loaded area 6 meter by 7.5 meter carries a load of 200 kPa. Determine the vertical stress at a point P located outside at a depth of 7.5 meters. Okay. So just draw it for you. Just draw. This is the location of P point. Okay, this is the location of P point. You need to find the pressure at this point P, which is located at this from top B. You are saying this, but it is at a depth of 7.5 meter. Okay, so this one you have to do. So how can we solve this? Previously we had a whole loaded area. The center we found out, right? So now how to do that? So for this, what we need to do is that we need to make the problem similar to whatever we solved in the previous class. Just now we have to deduct the other parts. So let us see. Everything will be clear. Okay, see the problem. It will be clear to you. So this one, what you can do, you can convert to something like this, right? So here we have this original box. Now from here I can extend it 3 meters, and from here I can extend it 1.5 meters, right? Okay. So we can divide it like this. So this one is right. Understood? So this one is, let us say, A1. Here's the original area. This one say A2, A3. Okay, right? So how can I get, so P point is located where? P point is located here. So how can we get, so from the total area, let us call it as, let us mark the points, right? Let's call it A, B, C, D, D, E, F, G, H, and this point is nothing but the P point. Okay, the P point. Now, what we can do is that this one we can get by how? 200. So 200 times at P at Z equal to 7.5 meter. How can we get 200 times K of AEPH? It is a large, big, complete big rectangle minus K of BFPH, right? BFPH, that is this, minus K of D E D E P G, this. So this portion got deducted two times, right? So that one we have to add once. Okay, so CFPG, right? So see if it is clear to you. Check once by yourself. See this one and check whether it's clear to you or not, whether you are able to get what we are trying to do or not. Please check. Got it right? AEPH minus BFPH minus DEPG plus CFPG. Okay. So now again, as usual, you have to use the your so this is the expression, right? This is our main expression, isn't it? Correct. Now for AEPH, what is M is L by Z. So Z is 7.5. What is L? AEPH, so 7.5 plus 3, 10.5. What is N? So what is B? 6 plus 1, 6 plus 1.5. This 6 plus 1.5, 7.5. So we can get mn is 1.4 n square plus n square. Find it out. 1.4 square plus 1 0.96 right, n square plus n square plus 1 is 3.96. Okay, so k a e h square root. Okay, so do it. Calculate this. Let us see if our answers match or not. So calculate this yourself, then match the answers with me. I will do it after some time, just 2 minutes. Just try it yourself. Do it by yourself first. So remember to convert this to radians, okay? Else you'll make mistake. Okay. So this is nothing but 0. Okay. So I hope you are getting this same values, getting the same values. Okay. Next, let us do for what BFPH. So BFPH, which one? BFPH. So BFPH L is 10.5 and D is 1.5. 10.5 and 1.5. Remember that. Okay, 1.4 and 1.2. So So again we can put all the values. Again find this out. Calculate the values. Zero 0.58. Okay. So next after that, next one, DEPG. So DEPG, let us see. For DEPG, L is 7.5, B is 3. So we'll just write okay. So I am not going to do it in detail. I will just give you the results here. So try to solve it yourself. Okay. Next we have CPG. For CPG, check how much is the uh, CFPG, actually not CFPG. L is 3 and B is 1.5. Sorry. Finally, this one comes out as 0.07. So the final answer is this one. Okay. Fine. So check the latter two values. Please do it by yourselves, and check the results once, fine. Okay, so that you can be sure of the results, so check, do it by yourselves properly and check the results once. Okay. Sorry. So can we move to the next question? The plastic. So read the question by yourselves. Okay, just try to read the question by yourselves and think whatever it's given. A very easy, direct question from the first, from the initial topics of index properties. Very easy question, very direct question. Directly, you just need to use the formula for shrinkage limit and shrinkage ratio. After understanding what are the facts that are given, you just try to read the question and solve it. Just these questions are very, this question is very direct, so you should be able to do this. So just try this in a minute. Try to solve this within a minute. So it's a very direct, it's a very direct question. Okay, everything is given, just you need to add. So the plastic limit and liquid limit of a soil are 30% and 42% respectively. The percentage volume change from liquid limit to the dry state is 35% of the dry volume. Similarly, the percentage volume of plastic limit to the dry state is 22% of the dry volume. So run the shrinkage limit and shrinkage ratio. C. Okay, so our Ethelbert limit curve is something like this, right? Something like this, isn't it? This side we have the volume, and this side we have the water content. Water content, right? Water content, and we have the volume along the pipe. Now this is the shrinkage limit. After that, we have the plastic limit, and then we have the liquid limit. That is given. Then the percentage volume change from liquid limit to dry state means here. This is what? This is liquid limit minus dry volume. So volume here is same, right? It is the same as the dry volume. So this is given, and also plastic limit to dry state. This is also given. Right. Now let us write the term. Say WP is given as 0.3 30%. Plastic limit and liquid limit is given as 0.42. Okay. Now VL minus VD is nothing but 0.35 of VD, and VP minus VD is 0.22 of VD. So all these are your given quantities. Right? Now, so what we are trying to do is we are trying to find the shrinkage limit. Now taking slopes, isn't it? VL minus VP by WL minus WP, like the this from here. This triangle we are taking. This triangle and VL minus VD and the larger triangle. These two triangles we are taking. Okay, these two triangles we are taking. So if we take this, we write like that. So VL is 1.3580 using these equations. All right. So if you do this, now it's purely math that you have to do, basic math. Yes. Find WS from here, calculate WS. WS is okay. Right? Am I right or wrong? Right, right? Because limit is 97%. Sorry, not 97, 9.7%. But 0.97, right? So 9.7%. Okay. Now next, one more thing we have to find out is the shrinkage ratio. Shrinkage ratio. Shrinkage ratio R. R is given as okay. So VL is 1.35. So that's 1.08. So this is how we found out the shrinkage limit and the shrinkage ratio. Okay. So first one we solved just by doing basic math, right? Just by taking slopes, and the second one directly solved by using the known relation. Alright, so this is how you need to solve the problem. Okay. Alright. So I hope that it is clear. It was clear to you. All right. Now do this problem. This you should do by yourself. Extremely easy problem from soil classification. So soil properties are given. Liquid limit, plastic limit is given. and some of the properties are given. You need to classify the soil. So do that while I wait for you to do. Okay, try to do this. Liquid limit is given, plastic limit is given, fraction passing through 4.75 C is given, and passing through 75 micron C is also given. So you just need to classify this. So liquid limit, plastic limit is given. It. So first thing, what is the first step that we need to do? What is the first thing that we need to do? So we need to find the plasticity index. Right? Plasticity index is 10%. After that, what we need to do? We need to find the plasticity index from A line. So before that, tell me what is the classification of the soil based on the granular part, whether it is a fine grained soil or whether it is a coarse grained soil. See, more than 50% is passing through 4.75 MC, as well as more than 50% is passing through 75 micron C. So obviously I can say that the soil is a completely fine soil, either a clay or silt. So if it is a clay or silt, how can I classify the soil? Low plastic, medium plastic, or intermediate plastic, or high plastic, based on plasticity we need to classify the soil, right? So we are doing plasticity index. I got plasticity from A line. What is the A line equation? 0.73 W minus 6%, right? And this is actually greater than 10%. That means what? That means our soil is actually lying below the A line. The soil is lying below the A line. So what if the soil lies below the A line? What type of soil is it? Clay or silt? If it plots below A line, clay or silt? It's plotting below A line, right? So what type of soil is it? Clay or silt? It is obviously what? Silt, right? Yes, it is silt. So first one is M. What is the suffix part now? Based on the plasticity, based on the liquid limit, we need to determine. The liquid limit is 40%, so between 35 to 50%, right? So it will be intermediate plastic, Mi. So this is the final soil classification. Okay. So I hope it is clear to you. The first one is whether it is a first you have to see whether it is a coarse grained soil, whether the soil is a coarse grained soil or whether the soil is a fine grained soil. That you need to identify at the beginning. Then if it is a coarse grained soil, how much fine fraction is there or fine fraction is there? You need to see. And if it is a fine grained soil, you need to see what is the Where it is above a line or below a line. If it is plotting above a line, then clay, below a line, then silt. And then after that, after you have decided this, if it is a fine grained soil, then you have to see the liquid limit. If it falls below 35%, then low plastic. 35 to 40, 50%, then intermediate. 50% is high plastic, right? This is how to do it. So tomorrow again we will be discussing everything from first to last. That time again all these concepts we will be brushing up. Okay. Tomorrow we won't be solving any problem. Just we will be revising everything from first beginning to the end. So next question: during a compaction test, the soil attains the maximum dry unit weight of 18.6 kilonewton per meter cube at a water content of 15%. So these are your optimum moisture content and the maximum dry density. This is given to you. The specific gravity is given 2.7 of the soil grains. Determine the degree of saturation air content at the maximum dry density. What would be the maximum theoretical density corresponding to zero air bursts at the OMC? Right? So you have solved these problems previously, right? You have already solved these problems. So just I will give you 2 minutes just to think on the problem and just to recap in your mind whatever you have studied. So you know how to do this. I will solve it obviously. Just try to think, recall everything and try to solve this yourself. In just think about it. I will give you 2 minutes. Just think on it for a bit. Then I will obviously I'm going to solve it. Just think on it. Think some time on it. So the maximum dry density is given, right? So from this what we can do, the maximum dry density to OMC is given. From here I can determine the degree of saturation, right? So this dry density E. So this one I can write as right? Now I hope you will be able to solve it. Just put all the values. 0.405. Do this one. 2.7 to 9.81 by 18.6. Do this. And tell me how much is it is coming. 2.7 to 9.81 by 18.6. It's 1.424. Okay, so from here I can get SS 0.955, that is 95.5. Okay, so degree of saturation you have found out. Now next thing that you have to find out is the air content. So air content also I have a simple expression for air content. What is air content? Volume of air by volume of voids. And what is degree of saturation? Volume of water by volume of voids. Right, so it is nothing but 1 minus S, so 0 0.5, 0.05, that is nothing but 4.5%. And last is the, what would be the maximum theoretical density corresponding to. So maximum theoretical density what? In this place you need, here you need to put S equal to 1 and find out, right? That will give us the maximum theoretical density. Theo max, nothing but, okay, so alright, so this is how. Very simple, right? You just have to recall all the basic concepts and try to solve the problem. Okay, let us see the next problem. A layer of saturated clay 5 meter thick is overlain by sand 4 meter deep. The water table is 3 meter below the top surface. The saturated unit weight of clay and sand are 18 kilonewton per meter cube and 20 kilonewton per meter cube, respectively. Above the water table, the unit weight of sand is 17 kilonewton per meter cube. Calculate the effective pressures on horizontal plane at a depth of 9 meter below the ground level. What will be the increase in effective pressure at 9 meter depth if the soil gets saturated by capillary up to a height of 1 meter above the water table? Very simple. A saturated sand layer is given, so we have 5 meter thick saturated clay layer. Above that we have 4 meter thick sand layer. The depth of the water table is given 3 meters below the top surface, means top in the sand layer. Saturated unit weights are given. Okay, all the unit weights are given. So what we need to do, we need to calculate the effective pressure on a horizontal plane at the depth of 9 meters below the ground. Okay, so that will do. So try to solve this yourself. Try to draw the diagram at least. Try to start. Then I will join. Just try to do it. Very simple. You should be able to solve all these problems, and because you already have solved each and every problem similar to this, right? So you should be able to do. So you are able to get this problem, right? So just simple. We have a layer, so like this. We have two layers. So this is 5 meter. This is 4 meter. Okay, so this is clay. This is sand. Water table is somewhere here. Okay, 3 meter below. So first we need to find the pressure here. Okay, vector pressure. So very simple. So all the unit weights are given, right? Unit weights of clay, sand, everything is given. So let us find the uh, total pressure first. So how much? 3 into 17 plus 1 into 20 plus 5 into 18, right? So do this, and then we have the pore water pressure. Pore water pressure is nothing but 6 gamma W into 6. Calculate this. Finally, effective stress is do this. It will be 161. Done. Now next what happens? Next, this told that this portion is saturated by capillarity. Then, if this portion is saturated by capillarity, then we need to find out the effective pressure. Okay. So again, what we will do? Now it's 2 into 17 plus it got saturated, right? So 20 into 2. That's right. It's a 20 plus 5 into 18. So how much is it, this one? 34 plus 40 plus 18 into 5. 164. Okay. Pore water pressure will be now how much? 6 meters, right? 5 plus 1 plus 1 to 6. So So due to capillary rise, what happened? The above portion of the soil also got saturated, and due to that we had an increase in effective stress, and the increase in effective stress was about 3 kilonewton per meter square. So due to 1 meter rise there, we had an increase in effective stress of about 3 kilonewtons per meter square. Okay, quite simple. Directly we have solved numerous problems like this, so there is no point of confusion, right? Okay, so can we proceed to the next problem? Right? Let's see this. So a permeameter of 100 dia with a sample length of 30 centimeter was used for constant head uh, and falling head test. While conducting a constant head test, the loss of head was 120 centimeter for the soil sample, and rate of flow was 3.2 centimeter cube per second. Find the coefficient of permeability. Okay. Then, if a falling head test was performed on the same sample at the same void ratio, find the time taken for the head to fall from 98 to 50 centimeter. The diameter of the standpipe when the falling head test was 25 mm. Okay, so two results from two permeameter tests are given. One is a constant head test, one is a falling head test. So first you have to find the coefficient of permeability from the constant head test, and then by using the coefficient of permeability from the constant head test, what you need to do? You need to find the time taken for the head to flow from 98 to 50 centimeter for the second test, in the second test, right? So same, we have, as far as I can remember, like similar problem we have solved before also, right? Just proceed, just try to solve the problem by yourself. I will give you just 2-3 minutes, then I will solve. Just try to solve this by yourself. So, constant head test. Let's write for the constant head test first. right? So do this, pi into 100 square by 4. Okay. Right? What is hydraulic gradient? The head loss by the length of flow. So what is the head total head loss? Is given that loss of at a 120 centimeter occurred, okay, right? And the head loss occurred along the sample length, right? The head loss occurred across the sample length, right? That's why length the flow the L is 30. Next, what is the flow? So 3.22 by I. So calculate this one. So this one you already know, right? KHLA. So you can have QLHAT. So this one also you can use to find this out. Okay, this one also you can use. So now for the following head test. So what is the area? So 3 log 10 h1 by h2. So this was the expression, right? So if you remember, so this was the expression 2.303 a by 80 al by 80 log h1 by h2, right? So now while the head loss from h1 to h2 we need to find out the time t. Time t we need to find out. So just k, just now you found out that k value will just put here. So from here you can find out t. So find calculate this one. Okay, please calculate. This one comes out as 1. So it takes 123.5 seconds for the head to fall from 98 centimeters to 50 centimeters. Okay, so it takes more than how much? 2 minutes, just above 2 minutes for the head to fall from 98.98 centimeters to 50 centimeters. Okay, so let us see the next problem. A 3 meter thick soil stratum has a coefficient of permeability 3 into 10 to the power minus 7 meter per second. A separate test have shown that a porosity of 40%, the bulk unit weight of 21 kN per meter cube at a moisture content 31%. Determine the head at which upward seepage will cause quicksand condition. What is the flow required to maintain critical conditions? Okay, so you have a 3 meter thick soil stratum and the coefficient of permeability is given, right? The porosity is given, the bulk unit is given, the moisture content is given. All these are also given. We need to determine the head at which upward seepage is called. That means critical head we need to find out. Critical hydraulic gradient or critical I value we need to find out. And also need to find out what is the amount of flow that needs to take place to maintain this critical. Okay. So let us so first what I suggest you first you please find out from porosity, find out the void ratio. Please find out E from N. Porosity is given, N is 0.4, right? 40%. From that value, first of all, please calculate the void ratio. Please calculate the void ratio first. So what is N? N is E by 1 plus, right? So from here, you can calculate E. Right? Next, what we need? We need the dry density. The dry density is gamma total by 1 plus W. So the bulk density is given as 21 at a water content of 31%. So from here I can get my dry density, right? I can get it. So you must remember this formula. We have used this formula regularly in our compaction chapter. We have used this many times in our compaction chapter, right? So we should remember this. So if we do this, we'll get okay. Next again, right? So from here so G I can get from here. So what is the G? What is the specific gravity of the soil solids? Comes out as P2. 2. I am also doing. You should also do by yourself. It is 2.72. Okay. Next, now I can find out the critical hydraulic return. So I critical was what? G minus 1 by 1 plus E, right? If you recall, nothing but G minus 1 by 1 plus E, isn't it? So now just put all the known values. G you have already found out just now. So this is find this out. So it is 1.03. Okay. Now the next part of the question is how much flow, what flow is required to maintain the critical condition? That is the next part. What is the flow required to maintain the critical condition? Okay, what is the flow required to maintain the critical condition? That we need. Okay, so for that we will use this. What is Q? So what is K here? K is given. A. Now, area I can calculate uh, what? What should be the area? So I will take unit area. Okay, unit area 1. So this will come out as 3.1 into 10 to the power minus 7 meter cube per second per meter square. Okay, so this much flow we should have per meter square of the soil in order to maintain this critical condition. Okay, the quicksand condition. Okay, next question. A 1 meter thick layer of saturated clay drained both faces, means double drainage condition from your consolidation topic. Double drainage condition, right? A 1 meter thick layer of saturated clay drained both faces, settles by 15 centimeter in 2 years. So in 2 years it settles by 15 centimeter. This 1 meter thick layer which is double drainage. If a thin layer of pervious soil is introduced in the middle of the layer, then what will be the period during the settlement of? So what we are doing is that initially we have a layer. This side also it can do. This side also it can. Now in between here we are introducing one more drainage layer. So we are reducing the drainage path further. Okay, we are having the drainage path. So if you have the drainage path, the question is now how faster will this settlement occur? From 2 years, what will be the reduced time? Okay, before it took 15 centimeter in 2 years, now you're reducing the drainage path. Now obviously the consolidation will be accelerated. The drainage is accelerated, so consolidation is accelerated. But with this acceleration of consolidation, now for 15 centimeter settlement, how much time will be required? That we need to find out, right? So then quite simple. So initially like this, right? So we have 1 meter thick. So this is drainage, this is drainage. Now we are introducing here again, right? So now the drainage path is reduced by half. So what is my basic equation? C T time factor equal to CVT by H drainage square, isn't it? Right? Now what is TV, TV directly relates to degree of consolidation, right? Now, T is proportional to, a time is directly proportional to my square of the drainage path. Square of the drainage path. So I can write like this: T1 by T2 equal to H dr1 by H dr2 whole square. Like this I can write. Now initially, when T1 was 2 years, what was my drainage path? What is my H dr1? Say H dr1 was what? How much? Half of 1, so 0.5, 1 by 2, 0.5 meter. Now, this T2 I need to find out. At this time, by introduction of the drainage path in between, now what is my drainage path? Drainage path is this. Drainage path is 1 by 4, it is 0.25 meter. Now let us see. If I put all the value here, square. So from here I can get 2 by T2. How much? 4. So T2 is nothing but 2 by 4, that is 0.5 years. Right. So before it was 2 years, now as the drainage path got reduced by half, the time is reduced to 0.5 years. That is the time is reduced by 4 times. So I will just write this for you here. If time reduces by 4 times. Okay. Time reduces by 4 times. Right? Quite easy. Now let us go to the last and final problem for today. So probably this problem is going to be the last problem for this session's this course. Uh, and tomorrow just we will be discussing all the theoretical concepts from past chapter to the end chapter, just revising in 1 hour. We'll try not to solve any questions, but if you have any doubt, any questions, I will solve, obviously. Okay, just we will discuss everything tomorrow to first class. Tomorrow we will try not to solve anything. Okay, but if you have doubt, if you want me to solve any problem, particular problem, please feel free to ask me. I will surely solve it. Okay. So this is the problem statement. A cylindrical specimen of dry sand was tested in a trying shell test. Failure occurred under a cell pressure of 1.2 kg per centimeter square and a deviator stress of 4 kg per centimeter square. Find angle made by failure plane with major principal axis, angle made by the plane of maximum shear stress with major principal plane, and shear stress on failure plane, and normal. So many things we need to find. Okay, so let us do one by one. First is the system is dry sand, and it is tested in dry shell test. Failure occurred under cell pressure. So cell pressure is this one. Cell pressure is about the minor principal stress, nothing but 1.2 kg per centimeter square. Okay. The deviatoric stress is 4 at failure is 4 kg per centimeter square. What is sigma 1? Sigma d plus sigma 3 is okay. Now C is 0, right? As it is dry sand, we can take C as 0. Now what is our basic equation? Sigma 1 is equal to right. So this is basically 0. So I have only this portion remaining. So from here if I put So from here, please find out phi. Please find out phi. Please find out the friction angle from here. Okay. Now, so 5 now the question is find angle made by failure plane with the major principal axis. So can you tell me? Can you recall what this was? Alpha. If you write it as alpha, what that was? Angle made by the failure plane with the major principal plane. What was that? That was 45 degree plus pi by 2. So nothing but this angle. So that is 64.5. Okay. Next, what we need to find out? Angle made by the plane of maximum shear stress. Right. So tell me what will be this angle made by the plane of maximum shear stress. So if you recall your more circles, the circles are like this, right? So so failure will be something like this. You are seeing, right? So the this so what is the where is the maximum shear? Maximum shear stress is right at the diameter point, right? This is this point. Now what is the now this is my major principal plane. So this angle is what always 45 degrees. So angle is nothing but 45 degree. Okay. After that we have so this 45 degrees is major principal plane. Okay, with major principal plane. Shear stress on the failure plane and normal. So what is shear stress on the failure plane is nothing but sigma 1 sigma 3 by 2 alpha. So this one we can do and shear stress on the normal stress on the failure plane is nothing but sigma 1 plus sigma 3 by 2 plus sigma 1 minus 2 plus 2. So we can find out. So the first one actually that is 1.56 1 point okay. So this is how you need to do this. Okay, so with this problem basically we will end the today's the problem this live interactive session, and tomorrow basically we will be having one uh, having a this last okay having the last basically summary session from uh, 12 noon to 1 p.m. That is 12 p.m. to 1 p.m. just for 1 hour. We'll be just discussing everything from the first to the end to end. From the first to the end, we will discuss everything. Just we'll revise. We'll try to recall. And if you have any doubts, you can ask me. Okay, you can ask me. I will try to solve any. If you want, I will try to solve any question. If you want me to explain any concept, I will do that. So already you should have received the reminder email regarding tomorrow's class, tomorrow's session. So tomorrow's session will be the last, the 13th session, or the you can call it as a summary session, and the summary session will be from 12 p.m. to 1 p.m. and we will be meeting tomorrow over the same link that we have been using throughout this course. Um, uh, along this for what to say 12 weeks or 3 months that we are together. And tomorrow we will be just wrapping up everything in 1 hour. We'll just discuss everything, and we will just if you have any doubts we will discuss, and then we will just end wrap up this course for this session, so that you can prepare and appear for your exams. And I hope that you have started preparing for the exams properly and nicely, and you should, I am hopeful that all of you will be performing very nicely, because a lot of problems were actually solved, and then problems are solved in the class also, and two discussion sessions were parallelly being run. Lots and lots of, you have lots and lots of problems to practice. So I am sure that your exam will be very good, right? So let us meet tomorrow at 12 noon, right? For 1 hour from 12 to 1. We will finish before lunchtime so that you can enjoy the later half. So just for 1 hour, we will meet from 12 o'clock to 1. I won't be solving, won't be having any set defined problem. If you want, I will talk. Else just we will discuss everything from the first chapter to the end. Okay, so with this we will end today's sessions. Thank you so sorry, thank you so much for attending, and I hope to see you all tomorrow again. Okay, thank you, and have a very good night. Thank you.